The second question of this week is again from chapter 1. So the question is, figure 1 shows two charges, Q1 plus 8 microcoulomb and Q2 negative 6 microcoulomb and placed 4 meter apart. So we have a distance here, okay, 4 meter, and also we have 2 points, point A and also point B. Okay, so let's just focus on the requirement of the question. What question asks us to find? Determine the electric field. Okay, the symbol for electric field is E at point A. Okay, so now you can ignore point B. We can just focus at point A. And let me remind you one more time, if we solve question related to electric field, is a vector. So first what we need to do is to sketch the direction. Okay, and only after that we can do the calculation. Okay, so in our case, okay, we are going to sketch the electric field at point A. At point A, so with respect to charge number 1 and also charge number 2. Due to charge number 1, our electric field is, so it's supposed to be outward. So we need to start drawing from point A. Okay, so it's supposed to be outward from positive charge, and label your direction. This is your E1. And then the electric field due to charge 2 is going to be, so it's going to be along this line, and charge 2 is negative, so it's supposed to be from point A. Your electric field 2, E2, is into the charge. Okay, so this is your E2. Okay, now this is your diagram. Okay, let us first calculate the value of E1. Okay, Q1 over R1. So the distance from Q1 and point A. Okay, so we substitute the values. So you'll get 9 times 10 to 9. Q is 8 micro minus 6 over 3 squared. Okay, then you'll have your E1 is 8,000 Newton per coulomb. This is the unit for electric field. And for E2 class, so it's going to be Q2 over R2 squared. So 9 times 10 to 9. Okay, so please remember we are not including the negative sign of the charge. Okay, we just want to get the magnitude. So 6 times 10 to minus 6. And the distance here is 5 squared. So why 5? Okay, so later we'll find why your E2 is equal to 2160 Newton per coulomb. Okay, so here is your triangle, and the distance here is 3, 4. Okay, you can simply guess, or by mathematical knowledge, you know that this is triangles. When here is 3, here is 4, and this is 90 degrees, then you know that here is 5. Or mathematically, you can calculate the distance here. Let's say it is x. So x is equal to square root. Then you'll have 5. Okay, so that's the method of knowing how do we get 5. Look at the direction that we have got. So we can see here that our E2 need to be resolved. Okay, so you're supposed to have E2x here. And also you're supposed to have E2y. Okay, E2x and E2y. And also you need to get the angle here to know the magnitude of E2x and E2y. And the angle is, we can do the calculation. Tangent theta is equal to 3 over 4. And your theta, you'll get 36.87 degree. Now we do our calculation. Okay, so we can have a table. Here is for E2. Okay, E1 and E2. And also E total. Okay, so for x component of x, for E1 we have 0, for y component, we have negative 8,000. So why negative? Because it is directed downward. And for E2x, okay, here is E2x, you are going to have, okay, E2 cos theta. So positive because it is to the right. So it's 2160 cos 36.78. Then you're supposed to have 1728. E to y, here is E to y, is going to be 2160 sine, your angle is 36.87. Then we find the total electric field for x-axis. Okay, so here is 1728, and here is total for y-axis. Then you're supposed to have negative 6704. Okay, so to get the total electric field, so total electric field is equal to, we use this equation, summation of EX squared plus summation of EY squared. Okay, now you substitute the values. This is for EX and this is for EY. So you're supposed to get your summation of electric field is 6923.12 Newton per coulomb. And also you need to find the direction. So for the direction, we are using tangent theta is equal to summation of EY over summation of EX. Okay, so theta is equal to, again, please do the substitute the values. So you will get 75.55. And you have to state the position. It is below positive x axis.